Today we are going to talk about timeline conventions and what to do if the cash flows don't conform to the standard timeline conventions in annuity and perpetuity formulas. First of all, the main convention is that the beginning of a project, the beginning of a savings plan, or today, is denoted by 0. Cash flows that occur at the end of a year are on the timeline at year 1. Now, on an income statement, these cash flows have accumulated over the course of the year from date 0 to date 1 and are recognized on the income statement at the end of the year. Now, cash flows that occur at the beginning of year 2 are actually at the same time. Cash flows at the end of year 2 are at the second point on the timeline. So, for example, often you will sell a business on contract where there's a cash flow today and several contracted cash flows in the future. Maybe $100,000 today, $50,000 for 2 years, $75,000 in 3. The way you would put that on a timeline and value it is that the initial cash flow is today. There are 3 periods. The cash flow that Joe receives today is $100,000. By convention, we sign cash flows. Money coming in is positive, money going out is negative. He receives $50,000 for each of the next 2 years, $75,000 in 3 years. If I wanted to value that, I wouldn't have to adjust the $100,000 received today at all, but I would have to add to that the discounted value of the $50,000 received in 1 year by dividing it by interest 1 time. The second cash flow divided by interest twice. The third cash flow divided by interest 3 times. Now, this isn't too bad to work out, but if there's a lot of cash flows that vary, your financial calculator can come in very handy. And the feature on your financial calculator that's designed to do this is the cash flow feature, the button right here. Enter cash flows, and whatever you were working with last time is still there. You hit second, clear work. This cash flow set starts with $100,000 today. And what you do is put the number in and then press the enter button. The little arrow sign, equal sign, comes up to tell you that it's been entered. You press down arrow, and it asks you what cash flow 1 is. It's $50,000. Enter, down arrow. Now, if you have a whole lot of $50,000 cash flows in a row, this is a register. The F01 register can be used to enter a large number of them. This would be the number of times you get them. If it's a small number, I recommend that people just put in every cash flow individually. So we'll hit down arrow here again. 50,000. One more time. 75,000. Enter. Now, the advantage of entering each cash flow separately is if you look at your timeline and you keep pressing the up and down buttons, CF0 is today, and each of the cash flows, the number of the cash flow, 1, corresponds to the point on the timeline where that cash flow occurs. Cash flow 1 at date 1 is 50,000. Cash flow 2 at date 2 is 50,000. Cash flow 3 at date 3 is 75,000. Now, to do the value of this today, what you would do is enter the net present value button here on your calculator. It asks you to enter the discount rate, the interest rate. Remember, your calculator takes these in percentage terms, so here it's 6%, enter, down arrow, and you can compute the value today. Press compute. So the value of this contract to Joe today is equal to $254,641. Now, when you're using formulas, or when you're putting annuities or perpetuities in your calculator, one of the problems is that the formulas assume a standard timing convention. They assume that the next cash flow will be next period. And the annuity formula and the perpetuity formula value those cash flows 1 period before the first cash flow in a series. The future value of an annuity values it on the date of the last cash flow. If those aren't the important dates to you, what you have to do is a two-step process. First, use the formula to get the value the period before the first cash flow or the period of the last cash flow. Then you can move that cash flow through time however you need to in order to get a date of interest. So, if you have a perpetuity that starts next period and goes forever, and it's $100, well then the value today is equal to that $100 divided by the interest rate, let's say 10%, 1,000. Fair enough, that's how the formula works. But what if the first cash flow isn't next year? What if the first cash flow is in year 2? Well, then if I plug it into the formula, I will get the value as of year 1. I'll call that P1. So this perpetuity is worth 1,000 a year from now. That's not the value today. In order to get the value today, the present value, call it P0, you have to take that 1,000 and discount it one more period. I'm sorry, 1.1. And that happens to be $909. Let's see an example of that in practice. Suppose you're thinking about taking out a loan to buy a combine for your farm, and the dealer offers you a $50,000 loan to buy a used combine and is willing to defer interest for 6 months. And we want to determine the payment. Let me lay out the cash flows that correspond to this on a timeline, and you'll see that there are going to be two conventions to that are just standard in most loans. So here's a timeline of this. Okay, first of all, the dates in the timeline. There's now, 0. And then when I say I'm going to defer payments for 6 months, that means my first payment is 6 months from now. On a timeline convention, a payment at the end of 6 months is at date 6. My last payment is 5 years from now. That's 60 months from now. If I defer payments for 6 months but make a payment at month 6, I have 60 minus 5, or 55 payments left. Now I count that on my fingers, or I make a timeline. If I make a timeline, I see I need to subtract 60. I need to subtract 5 from 60 to get 55. If I just kind of randomly say, hey, we defer payments for 6 months, so I need to subtract 60 minus 6, I'm going to get 54. It's actually not the right number of payments, because deferring for 6 months means that you make their first payment in 6 months, that is, on month 6. So counting is important, and a timeline helps a lot. The second thing is if I use the annuity formula, I'm going to get the value as of year 5. Well, month 5 in this case. Fair enough. And let's see, the interest rate on this was 9. So the monthly rate is 9 divided by 12. And how many payments are there? There's 55. But I don't know the value of the loan in date 5. I know that the loan is worth $50,000 today. Now I need to get these two sets of cash flows to equal each other in value on a date. So using the annuity formula alone doesn't quite accomplish that. What I'll do is I'll just one or the other of them so that they're on the same date. Now notice, the annuity formula brings the payments back to one period before the first payment, to period 5. So whichever is convenient, I can bring that back to today by dividing by 1 plus interest 5 more times. Or, in this case, it's more convenient to bring the $50,000 forward by multiplying. Sorry, that's the worst 5 I've made lately. I'll try it again. By 1 plus interest 5 times. Then I can equate these two, and I can find the payment. Now I can do that algebraically pretty easy. So I'm going to do it. So the left-hand side is $50,000 carried forward for 5 months. The right-hand side is equal to this entire term. But I can move that entire thing to the left just by multiplying by 9% over 12. And then dividing both sides by the adjustment factor for the annuity. Yeah, didn't write that right. Hang on. And I can actually solve that pretty easily, but really, this is what your calculator is for. In this case, the present value, this is the amount I owe, is $50,000 plus interest 5 times. And the amount I owe, I'll make that negative. And then my payments are here. 9 over 12 is interest. 55 is n. There's no future value. So this is very easy to solve in your calculator in a 2-step process. First, let's see what the $50,000 is going to be worth in 5 months. 51,903. That's going to be my present value. Well, let's see. I said I was going to make that. Well, it doesn't really matter. Let me say that I'm going to make that positive because that's the amount they've given me. So it's kind of like a cash inflow for me. Then what happens? I want to pay this off to a future value of 0 over 55 months at an interest rate of 9% divided by 12, 0.75% per month. Compute the payment, $1155.16. Now, the annuity and perpetuity formulas follow the standard. Present value, 1 period before first cash flow. Future value, date of last cash flow in an annuity. But many times, that is not the actual pattern of cash flows. The annuity starts, in this case, in 6 months. The perpetuity might have started 5 years ago. The way you solve all those problems is like this, in a 2-step process. Find the value, the period before the first cash flow, or the date of the last cash flow, and then adjust it through time as needed to get to the date that works to solve your problem.